Hello, this is Sadie Ray, and today I am bringing you the Mayneord F Factor. Since the irradiated volume for a given field is decreased when the SSD is increased, we must adjust our PDD because of the change in distance. This is because our PDD chart is calculated in respect to a certain reference point. In this example, our chart is for a 100 centimeter SSD. We can use the Mayneord F factor because it is a reasonably accurate method of calculating the change in the percentage depth dose for small fields. It is important to note that the Mayneord F factor should not be used with low energies, large fields, large depths, or large changes in SSD. In our previous example, the PDD for our scenario was 83.2% at an SSD of 100 centimeters on our 6 megavolt beam. So let's examine the Mayneord F factor. We will take the product of the original PDD and the SSD of our new distance plus the Dmax of the energy being used over the SSD of the original position plus the Dmax of the beam energy, which is squared and then multiplied by the original SSD plus the depth being treated over the new SSD plus the depth squared. Now, let's recap our previous example before we apply the Mayneord F factor. We had a 6 megavolt beam that we were using to treat to a depth of 6 centimeters. Our monitor unit formula looked like this. You can see the PDD of 0.832 in our equation, which led to 358.1 monitor units. Our new SSD will be 110 centimeters slightly further than the original SSD of 100 centimeters. The Mayneord F formula will look like this. As you can see, we have plugged in the values for our original PDD, the new SSD, the old SSD, the Dmax for our 6 megavolt beam, and the depth we are treating to. The new PDD, adjusted for our new distance of 110 centimeters, is 0.839. Plug that back into our original monitor unit formula and we get 355 monitor units. The Mayneord F factor can also be used for shorter distances as well. Thank you for allowing me to bring you this presentation, and I hope you have a pleasant day. This is Sadie Ray signing off. Ciao!
This presentation was created by Nelson Colon.